Chapter 6, Percentages and its Applications. This particular chapter right here is we're going to cover the conversions and base part and rate, percent of increase and a percent decrease type of problem. This is a table of contents for a handout that is in a PDF format that's located in your learning management system, so you're welcome to download it and print a copy of that as well. In the meantime, I'm going to go ahead and move forward to Chapter 6. And percents are expressed as hundredths, that's ending with THS. So 1% means 1 of 100 equal parts. Therefore, 2% is 2 of 100 equal parts. The other types of conversions that we'll be working with, we have about four or five different conversions. And the first one is to express a decimal as a percent. This one's really easy because when you go from D to P, decimal to percent, alphabetically, you're going to go to the right. So you're going to move the decimal point 2 places to the right and then add a percent sign. So, for example, we have the 0.4, and we're going to go 2 places to the right, D to P. That gives us 40%. 0.5 or 5/10 is equal to 50%. 875 thousandths turns into 87.5%. And then 1 and 75 hundredths turns into 175% after you move the decimal point 2 places to the right. Okay, now to express a decimal as a percent as a decimal, now we're going to go backwards. Instead of moving 2 places to the right, we'll move 2 places to the left. We'll start at the decimal point if one's given. If it's not, it's probably where the percent key is located, a percent sign is located. So in the very first one, we have 40%, so it doesn't have a decimal, but it's a whole percent, so it's almost assumed, it is assumed that 40 is a whole number, and the decimal point is just to the right of it, right where the percent sign is. So we're going to start at the percent sign and move the decimal point 2 places to the left, which is 0.4, and that gives you 4/10. Okay, 50% gives you 5/10. 87.5%, move the decimal point 2 places to the left, since it exists right there within the value, and that turns into 875 thousandths. 175% turns into 1.75, or 1 and 75 hundredths. Now, number 3, to express a fraction as a percent. Okay, whenever you start out as a fraction, you first convert it to a decimal and then convert it to a percent. So you're going to first divide the numerator by the denominator, which will provide a decimal value, then convert that decimal to a percent, D to P, so we'll move the decimal point 2 places to the right and then add the percent sign. So 1/4, if I entered 1 divided by 4 on the calculator, it would give you a decimal percent of 0.25. Move that decimal point 2 places to the right to give you 25%. Then 3/5, I would enter 3 divided by 5 on the calculator, and that would give you the decimal value of 0.6. Move the decimal point 2 places to the right to give you 60%. And then finally, you have 7/8. Enter 7 divided by 8 on your calculator, and that would give you 0.875. And then to convert that to a percent, move the decimal point 2 places to the right to convert it to 87.5%. Okay, now we're going to go into number 4. Okay. Okay, number 4. To express a fractional percent as a decimal. What a fractional percent is a fractional, it's a fraction with a percent sign that has a value of less than 1%. First thing we're going to do is change the fraction to a decimal by dividing the numerator by the denominator. Then move the decimal point 2 places to the left. So if you have 1/5 of 1%, I'm going to enter 1 divided by 5 on the calculator to give you 0.2%. Then I'm going to move the decimal point 2 places to the left to give you 0.002 or 2 thousandths, because 2 is in the thousandths location. Then 3/4 of 1%, I'll enter 3 divided by 4 into the calculator, which would give you 0.75, and then convert that percent to a decimal. I would move the decimal point 2 places to the left to give you 0.0075, which reads 75 10,000ths with a THS on it. Okay, 1/8 of 1%, I would enter 1 divided by 8 on the keyboard, on the calculator, and that would give you 0.125%. Move the decimal point 2 places to the left, and that would give you 0.00125. That would read 125 10,000ths. 100,000ths rather. So that's tenths, hundredths, thousandths, 10,000ths, and 100,000ths. So 125 100,000ths. Okay, number 5, to express a percent as a fraction. So you have just a regular percent, such as 5%. All I'm going to do is take 5% and put it over 1 and then multiply it to 1/100th. Okay, I can use the cancellation method on this multiplication problem and reduce it down to lowest terms that way. 5 will go into itself 1 time. 5 will go into 100 20 times. So that equals 1/20th. Okay, so the last one, to express a percent as a fraction, you might have something like 5.5%. First thing that we're going to do is convert that 5.5% to a improper fraction. So 5 times 2 is 10 plus 1 is 11, so that's going to equal 11 over 2. And then multiply the improper fraction times 1/100th. Okay, then multiply across, and that would equal 11 200ths. Okay, now if you have a decimal percent that doesn't express itself in a fractional value, convert it to a fractional value because that'll make it easier. Okay, 7.25% is the same as 25 over 100. Okay, 25 will go into itself 1 time, and 25 will go into 100 4 times. So that, in essence, is equal to 7 1/4. I want to convert that 7 1/4 to an improper fraction, which is 7 times 4 is 28, plus 1 is 29 over 4, and then multiply that times 1/100th. And that is equal to 29 times 1 is 29. 4 times 100 is 400. 29 400ths. Okay, so there's the conversions. Now we're going to look at base, part, and rate. This is really one of the great things about this particular chapter. It's the foundation of everything that we do from this point on throughout the entire semester in almost every single chapter. So you really need to have a good understanding of this particular chapter. You're only going to solve for one, 2, or 3 of the different types of values, whether it be part, base, or rate. And you have to know which each of those components represent. Once you do this, you'll be able to do every chapter much more successfully than you would without having this information. First of all, base is usually the starting point, that to which something is being compared. The base is the overall picture. It's a big, if you take a look at a pie, it's the whole pie. And then a portion of that pie represents the part, which is the third component. The part is a portion of the entire base. For example, a sales tax represents a part or a portion of the entire sale amount. Additionally, sports cars represent a part or portion of all the cars manufactured. The rate is really easy because it's identified with the percent sign or the word percent or the words rate percent. Okay, so there's 3 formulas in this particular chapter, and that is for the part, base, and rate. Okay, so I've set it up in this particular pyramid. The part is in the point. Part starts with a P and point starts with a P. So part is in the point. Okay? Base is in the bottom and rate is in the right. Rate starts with R, which is in the right. Base starts with B, which is in the bottom. Part is in the point, which starts with P. Okay, this horizontal line right here represents the division. And the vertical line right here represents a multiplication. So if I am solving for the part, I cover up the part, and that means that the value would be base times rate. Okay, if I'm solving for the base, I want to cover up the base, and that means it's part divided by rate. Okay, if I'm solving for the rate, I cover up the rate, and that means it's part divided by base. Those are the 3 calculations that we will use in this particular section. Okay, and then there's a summary immediately below that. Okay, here are some problems that we'll work with. I'll blow it up a little bit to give it a little bit more space. We're going to identify each of the 3 components in each one of these questions. 4% of 50 is some number. It's easiest to identify the rate because there's a percent sign next to it. So here's the rate. And the number that follows percent of is usually the whole value. This is a complete piece of the puzzle. So the number that follows percent of is generally the base. And the number that's associated with is or equal is your part. So in this particular case, we're solving for the part. Part is equal to the base times the rate. So the base is 50 times the rate of 0.04. Well, you're going, wait a second, that says 4%. Well, you're going to move the decimal point 2 places to the left to establish it as a decimal. So 50 times 0.04 is 2. The whole number of 2. So the part is equal to 2. 4% of 50 is 2. Okay, and you can think of it this way. If the question was 10% of 50 is some number, well, 10% of 50 is 5. So 5% of 50 is 2.5, and that means 4% of 50 is 2. So you can kind of see the relationship there. Okay, number 2, 1.2% of 180 is something. Again, it's easy to identify the rate because the percent sign's associated with it. The number that generally follows percent of is your base because that represents the whole value of something. And then the number associated with is or equal is your part. So again, part is equal to base times the rate. So we're going to take 180 times 0.012. It's because we moved the decimal point 2 places to the left. Okay, therefore, 180 times 0.012 is equal to 2.16. So again, the part is equal to 2.16. If we rounded that to the nearest tenth, it'd be 2.2. So 1.2% of 180 is 2.2 when rounded to the nearest tenth percent. Okay, then number 3. 1/4 of 1%. There's a fractional percent, so the conversion's up in one of the previous statements. We can kind of review that a little bit. Whoops, I did not mean to mark on that right there. Let me kind of clear that up. Here is the conversions right here. When you have a fractional percent, number 4, first you convert it to a decimal percent and then move the decimal point 2 places to the left. So that's exactly what we're going to do right here. Okay, so we have 1/4, 1 divided by 4 on the calculator is equal to 0.25. Then I'm going to 25%. I'm going to move the decimal point 2 places to the left to make it a decimal of 0.0025. So that's recorded right down there. By the way, that 1/4 of 1% is the rate since it's associated with the percent sign. Then the number that follows percent of is your base. Again, we're solving for the part that's associated with is or equal. Okay, so part is equal to base times the rate, and the base is 560 times 0.0025. Okay, that equals 560 times 0.0025 of 1.4. Okay, so 1/4 of 1% of 560 is equal to 1.4. Okay, now let's go ahead and move to the next section. And we have 32 is 33 1/3% of some number. Okay, so it's easiest to identify the rate. Okay. Because of the percent sign. The number that usually follows percent of is what you're comparing something to. That's your base. The number associated with is or equal is your part. So in this case, we're solving for the base. And the base is equal to the part divided by the rate. Okay, so that's 32 divided by the rate. Now remember, it's 33 1/3. Right here is the way it would display. 33 1/3. If you put 1 divided by 3 on your calculator, it's going to be 0.33333 into infinity. Just round it to the nearest thousandths. So you have 33.333 when you round it to the nearest thousandths. You don't have to put all the additional threes. And your book is based upon the thousandths. So you'll come out more correctly by rounding it to the thousandths. And then, since that is the percentage, I want to move that to a decimal, so I want to move the decimal point 2 places to the left. That makes it 0.33333, as illustrated right there. So now the base is equal to part divided by rate. So that's 32 divided by 0.33 333. And that's going to equal 96. If you round it to the nearest whole, that one is 96.00096. So we're going to round this one to the nearest whole number. And so your base is equal to 96. So therefore, 32 is 33 1/3% of the whole piece of the pie, which is 96. Okay, number 5, 14% is easily identified as a rate. The number that follows percent of is your base. The number associated with is or equal is your part. So again, this one's part, which is equal to your base times the rate. So the base is 780 times 0.14, because I moved the decimal point 2 places to the left. And the calculation for that, or the result of that calculation, is 109.2. So 14% of 7 to 80 is equal to 109.2. Okay, let's take a look at number 6. Okay, the rate is unknown. That's what I'm solving for. And the number that generally follows percent of is your base. The number associated with is or equal is your part. So we are solving for the rate. The rate is equal to the part divided by the base. Okay, so the part is 13,830 divided by 78,400. And that equals a decimal value of 0.1764 0306. Okay. Now, to convert that decimal to a percent, move the decimal point 2 places to the right. Let's round this one to the nearest 10%, so that'll make it 17.6%. So 1380 is 17.6% of 78,408. Okay, let's move up to the next one, number 7. Okay, 15 is 12.5% of some number. First of all, I can recognize the 12.5% as being the rate. And then the number that follows percent of is your base. And the number associated with is or equal is your part. So we're solving for the base. And the base is equal to the part divided by the rate. Okay, 12.5 is 12.5. I'm going to move the decimal point 2 places to the left to make it 0.125, as illustrated right there. Okay, so base is equal to part divided by rate, which is 15, divided by 0.125, and that equals 120. So the base is equal to 120, which means 15 is 12.5% of 120. Okay, now number 8. 5% is easily identified as a rate. The number that follows percent of is your base. The number associated with is or equal is your part. So we're solving for part, which is equal to the base times the rate. Okay, that's 680 times 0.05 after I move the decimal point 2 places to the left. And that will equal 34. So 34 is 5% of 680. Okay, number 9. 33 is 3% of some number. You can easily identify the 3%, which is a rate. The number that follows percent of is your base. The number associated with is or equal is your part. So we're solving for base, and base is equal to part divided by rate. So that's 33 divided by 0.03 after I move the decimal point 2 places to the left. And that equals 1100. Therefore, 33 is 3% of 1100. Okay, let's scroll up to number 10. Some percent. Okay, we don't know what the rate is here. The number that generally follows percent of is your base. The number that's associated with is or equal is your part. So rate is equal to part divided by base. So that's 36 for your part divided base of 720. And whenever you do this on the calculator, it will give you a decimal value of 0.05. Just move the decimal point 2 places to the right to establish the decimal as a percent, D to P, so that equals 5%. So 5% of 720 is 36. Okay, we have a fractional percent on number 11 again, so that's, we'll identify the parts first, which the percentage is the rate. The number that follows percent of is your base. The number associated with is or equal is your part. So we are solving for the part, which equals base times the rate. Okay, so that's going to be 1,500 times 0.0025. How did I get that? That's 1 divided by 4, which is equal to, on your calculator, is 0.25. And technically it's 0.25%. To convert that percent to a decimal, move the decimal point 2 places to the left to make it 0.0025. Comes around right there. So 1,500 times 0.0025 is equal to 3.75. So 1/4 of 1% of 1,500 is 3.75. Okay, here's some conversions beginning with number 12. The fractional equivalent of 8% is, just put 8 over 1, multiply that times 1/100th, and by the way, 4 will go into 8 2 times, 4 will go into 8 2 times, and 4 will go into 100 25 times. So that gives you 2 times 1 is 2, and 1 times 25 is 25, which gives you 2/25. Okay, number 13. Here's another conversion. The fractional equivalent of 87.5% is, first of all, is 87.55. It's like this. 87.5. This 0.5 is in the tenths location, so that's the same as 5 over 10. Reduce that down to 1. 5 will go into 10 2 times, so 1/2. So really, this is 87.5. Convert this mixed number to an improper fraction. 87 times 2 is 174, plus 1 is 175, over the like denominator of 2, which is this one right here. Multiply that fraction times 1/100th, and that gives you 175 over 2,000, and break that down to 7/8 for the final answer. Okay, the fractional equivalent of 0.375 is, okay, what I'm going to do here is I'm going to convert this decimal to a mixed number, which is the same as 37.5. And then that 5 is in the tenths location, so it's the same as 5 over 10. 5 will go into itself one time. 5 will go into 10 two times. So this is the same as 37.5. Okay, convert that mixed number into an improper fraction. So 37 times 2 is 74, plus 1 is 75 over 2. Take it times 1/100th. And I can break this down. 25 will go into 75 3 times. And 25 will go into 100 4 times. So 3 times 1 is 3. 2 times 4 is 8. So 3/8 is your final answer in fractional as a fractional equivalent. Then we have a fractional equivalent. What is a fractional equivalent? 1/2 of 1%. Just take the 1/2 times 1 over 100. Multiply 1 times 1 is 1. 2 times 100 is 200. Give you 1/200ths. Okay, let's look at a couple of word problems. Okay, a stock selling for $25 a share pays a 3% dividend. Find the dividend for each share. So the base, I need to find the base and the part and the rate. It's easy to find the rate because there it is right there, 3%. Okay, the whole value of the share is $25. So the 3% is the rate, and the whole value of the share is the base, that to which something is being compared, and we're looking for the dividend, which is representative of the 3% of that $25. So therefore, we're looking for the part. So part is equal to base times rate, especially if you use the symbol right here. Part is in the point, base is in the bottom, rate is in the right. So we're going to put 25 right here for the base. And the rate, we're going to make it 0.03 when we move the decimal point 2 places to the left. And so 25 times 0.03 gives us the part, or the amount of the dividend, of 75 cents for each share. Okay, the next one is a salesperson at a store finds that the canceled sales, canceled's misspelled right there, it should have only one L. A salesperson at a store finds that canceled sales amount to $560 each month. If that amount of $560 is 0.5% of the total monthly sales, find the total monthly sales. Well, first of all, I know that 0.5% is the rate, and I know the total monthly sales is the base, the total amount to which we're comparing it to, because 0.5% is representative of the $560, which is the part. So therefore, I'm looking for the base. The base is equal to the part divided by the rate. So that's 560 divided by 0.005. How did I get that? 0.5 of 1%. You have 0.5, and then move the decimal point 2 places to the left to equal 0.005. 560 divided by 0.005 equals 112,000. So a salesperson at a store finds that canceled sales amount to $560 each month. If that amounts to 0.5% of the total monthly sales, the total of monthly sales must be $112,000. Okay, now we're going to look at something a little bit different in these next two components, and this is a percent increase. A percent increase usually can easily be identified whenever you, it's really the part is equal to the base plus some other part of the base. To identify an increased percent problem, look for more than last year or greater than last year's or greater than the previous quarter or something to that effect. Since you will be likely comparing last year to this year or last quarter to this quarter, always assume that last year, the year you're comparing it to, is 100% of the value, so that your rate will be 100% from last year plus the percent increase for this year. And then you add those two together. So therefore, if sales are $121,000 this year, and this is a 20% increase over last year's sales. What are last year's sales? Well, last year's sales is going to be the base. The part is this year's sales as a result of the 20% increase over last year, which has a full value of 100%. So the part is this year's sales of $121,000. The rate is 100% from last year plus a 20% increase this year to give us 120%. Then move the decimal 2 places to the left to make it 1.2 for the entry that you'll use for the calculator. So if base is equal to part divided by rate, the part is this year's sales divided by the rate of 1.2, and that will give you last year's sales of $100,833.33. So in other words, if sales are $121,000 this year, and this is a 20% increase over last year, that means that last year's sales were $100,833.33. Prove it. Right down here in this particular section, first of all, if I take last year's sales of $100,833.33 and multiply that times 20% or 0.2 after I move the decimal point 2 places left, that means I'm going to have an increase from last year to this year of $20,166.67. So add that to last year's value to equal this year's value of $121,000. So you can prove your work in this particular case. Okay, let's try this one. This is kind of tacky. At Home Depot, sales this year for air conditioners are 1,452 units. So that's how many units we sold. This is a 10% increase over the number that we sold last year, which is also a 10% increase over the year that we sold the year before. So we want to find the number of units at Home Depot sold 2 years ago. Well, let's just work it back 1 year at a time. Since we know that there's a 10% increase from last year to this year, we know that we want to take last year's value of 100% plus a 10% increase to give us 110%, or 1.1 when we move the decimal point 2 places to the left. Okay. Since this problem has 2 years increase of 10% for each of the years, do not add the percentages together. Instead, assume that each year's rate is 110% over the previous year's rate. Okay, I want to scoot that up just a little bit. So, therefore, if we're solving for last year's sales, which is 100% of the value, that's our base. Our base is equal to the part divided by the rate. The part is this year's sales. We sold 1,452 units. We're going to divide that by the rate of 100% from last year plus a 10% increase, which gives us 110%, and then move the decimal point 2 places to the left to give us 1.1. So that's 1452 divided by 1.1, which equals 1320, and the 1320 is last year's sales. This year we have 1,452 units that we sold. Last year we have 1,320 units that we sold. So now that we've taken care of last year to this year, let's go ahead and look at the number of sales that we had last year, which is 1320. We're going to divide that from the previous year by the rate of a 100%, because that's the year that we're comparing it to now, plus the 10% increase that we got from 2 years ago to last year. So that again, 110%, move the decimal point 2 places to the left, which is 1.1. So this time it's 1320, last year's sales divided by 1.1. That's going to equal 1,200. That's the sales for 2 years ago. So now let's isolate this. The sales 2 years ago, 1,200 units were sold. And with a 10% increase, we sold 1,320 last year. And with a 10% increase, we sold 1,452 this year. Let's prove that. Let's kind of work from the back end out. Let's go 2 years ago, and we'll start right here. 1,200 times 10% increase, or 0.1 after I move the decimal point 2 places to the left. That means I sold 2 years ago 1,200 plus 120 more for the next year to give us a total of 1,320. Then I took 1,320 for that year's sales times 10% increase, or 0.1 after moving the decimal point 2 places left, meaning I sold 132 extra. To add that to last year's sales, and that gives us this year's sales of 1,452, the number of units I sold this year. So I was able to work through this particular problem to determine if I did it correctly. Okay, now let's switch gears and look at a percent decrease problem. And a percent decrease is very similar, but it shows a decrease from 1 quarter or 1 year to this year. So with a decrease problem, the part is equal to the base less some part of that base. To identify percent decrease problems, look for after the reduction of, less than last year, or after the decrease of last year. Look for those phrases. Since you will likely be comparing one period to another, the original year that you're comparing it to is 100% less the decrease for this year and or period. So therefore, after withdrawing 25% of his savings, a depositor has $1,500 remaining in his account. Find the account balance before the withdrawal. So the full value of his account is the base. That's what I'm comparing this all to, the original amount. Now I have the part remaining, which is $1,500. The balance before the withdrawal is my base, and the decrease from the original to the current is my rate. So I'm going to solve for the base, which is equal to part divided by rate. So my part is what I have now of 1,500 divided by the rate. I'm not going to find out how many dollars I actually decreased in. I want to find out what the original amount was. So therefore, I'm going to divide that by 0.75. So 100% from last year, and then I had a 25% decrease, which gave me a 75% value to find the amount before the withdrawal. So 1,500 divided by 0.75 equals $2,000. That's the amount before the withdrawal. $1,500 is the amount after the withdrawal. Well, I can see very clearly that there is only a $500 difference between the original and the amount after the withdrawal. But I can still check this problem. I can start with what I originally had of $2,000, And I will take that times 25% this time, or 0.25 after I move the decimal point 2 places to the left. That tells me the amount of the withdrawal of $500. Subtract 500 from the original, and that gives me the amount after the withdrawal of $1,500. So that's the way that I actually work it out to make it work for me. Okay, this concludes Chapter 6. Work through the drill problems at the end of the chapter or in your Connect activities. And then also, in addition to the drill problems, at least the first step of the drill problems, then go directly or specifically to the summary practice test at the end of Chapter 6. Then you can check your work and watch a video that's sponsored by the publishing company that takes you through every one of those questions in your summary practice test. This concludes Chapter 6.